Okay, so yesterday we started looking at triangles. And what is it about the three interior angles that was the largest focus of our lesson? Hank?
They add up to 180.
Very good. They add up to 180 degrees. What happens if I give you three angles and they do not add up to 180 degrees?
It's not a triangle.
It's not a triangle. Nice and simple there. So let's see. I'll give you 25, 65, and 90 degrees. If these are three angles, can they be the three angles in a triangle? Harrison and Ayla say yes. Why do y'all say yes? It adds up to 180, so these three could create a triangle. 30 degrees, 70 degrees, 81 degrees. Can these three angles be the measure of a triangle? Fisher?
No.
Why no?
It's 1 over 180.
Very good. It does not add up to 180, so it cannot be a triangle. That's simple enough, correct? All right. What we're going to be looking at today is the side lengths. We know that the triangles have to have 180 degrees inside, but now we're going to look at the lengths of the sides. Like if I gave you three specifically measured sticks, could you put them end to end and build me a completely closed-in triangle? That's what we're going to be testing today. Now, your notes have this. We're on page, I have absolutely no idea. It's the page after yesterday's stuff. So 1, 2, 3, 4. Page 6, if you do kind of a front back count. And it starts talking about the properties for triangles when we're talking about their sides. And I'm going to assume we don't like to read a lot of words. Am I correct?
Correct.
Okay. I'm the same way. So we're going to go over one more page. And it gives us this example. And we want to determine if 5 centimeters, 8 centimeters, and 12 centimeters, if those were three lengths, could they create a triangle? Now, it did 3 different math problems here. I don't know about y'all, but I don't want to do 3 math problems for one problem. Josh says no. Alex said nuh-uh. We're going to do 1 math problem. Okay? Do we really want this recorded? Let's just leave his crock alone. All right. So instead of doing 3 math problems, we're going to work smarter, not harder. And this is where I want us to focus. We're going to take the 2 small sides and add them together. And we want to see if they are greater than the longest side. 1 math problem instead of 3. Okay? And it'll make lots of sense as we start kind of doing these. 5, 8, and 12. What are the 2 small sides there? 5 and 8. So we're going to add together the 2 small sides. And we want to know if it is larger than the longest side that we were given. Daniel, what's 5 plus 8? 13. So we have 13 is greater than 12. Is that true? Yes. So these 3 lengths can form a triangle. Notice it cannot be equal to, and it can't be less. It absolutely has to be greater so that we can get that point on top of our triangle. Let's look at the next one. Determine if the sides of lengths 3, 4, and 9 can create a triangle. It says to do 3 pairs of work. No, we're just going to do the 1. We want to add up the 2 smallest sides. What are the 2 smallest sides given to us? Okay, so we want to add the 3 and the 4, and we want to know, is it greater than the third side? And 3 plus 4 is? 7 is greater than 9. Nah. So no triangle is possible with those 3 lengths. Kind of catching on?
What?
What?
Oh, they're supposed to add up and be equal?
It has to be bigger.
The left side has to be bigger than the right side?
Yes, the 2 small sides have to add up to be bigger than the third side.
Oh.
We're going to do some more of them. Let's look here. Determine if the triangles can be formed. They gave us 3 lengths. 4 centimeters, 7 centimeters, 10 centimeters. I want the 2 small sides first. Which 2 are the smallest? 4 and 7. So we're going to add 4 plus 7 and see if it's greater than 10. What is 4 plus 7? 11. 11 is greater than 10. Yes or no?
Yeah.
That is a yes. So those 3 measurements can create a triangle. Number 2. Cordy, what are the 2 small lengths on number 2? The 2 smaller numbers.
Wait. Oh, the 24 and 20?
So we're going to add those together. And we want to know if that's going to be greater than the third side.
It is.
How do you know?
Because it's going to be 44.
And 44.
It's greater than 30.
Correct. So these 3 can make a triangle. Number 3. What are the 2 small sides? Fisher?
7 and 9.
7 and 9. So our inequality is going to be 7 plus 9 is greater than 16. We do our adding. 7 plus 9.
16.
So 16 is greater than 16. No. So no triangle. So it can't be less and it can't be equal. It must be greater. On number 4, what are the 2 smallest sides, Cam, who's not supposed to be eating in my class? 9 and 13. What's my inequality going to say? Let's start at the beginning. What am I going to do with the 9 and the 13, Josh?
Oh, I got it now.
Huh? Add them together. So 9 plus 13 needs to be greater than 24. 9 plus 13 is? 22 is greater than 24. Nah. So no triangle is possible. This is what we're testing. Okay? Take the 2 smallest, add them together, see if they're bigger than the third. You do this one. I want to know if the side lengths of 5 millimeters, 14 millimeters, and 19 millimeters can form a triangle.
I'm so smart.
And you have to be prepared to explain it.
Wait, so if it equals it, what does that mean?
It's not a triangle.
So it
Has to be greater. That's the only way they can, catch and create the point on the top. Let's go with Norman. Yes or no? Norman, you say no. What inequality did you set up?
5 plus 14 is greater than 19.
Good. 5 plus 14 is greater than 19. And what did you find?
19 is greater than 19, but that's false.
Yeah. 19 is greater than 19 is false, so there is no triangle possible here. Very good. All right. I want you to turn the page and I want you to complete the next 7 questions. Make sure you write the inequality to support your answer. And this part of class won't be recorded because it's not on the slides. Okay, good job on those. And I want you to turn the page. And we've looked at angles. Angles have to equal 180 degrees. We've looked at the side lengths. When we do the sides, the 2 smallest have to be greater than the longest side. But now we're going to take that one step more and we're going to look at if the triangles are unique, meaning only one triangle can be built, or it's not unique and every person in this room could build a different triangle with the same characteristic. Okay? I don't necessarily like this table. If you like it, great. But I like to use something different, but unfortunately you're going to have to write it down for yourself. Okay? It's this. Now, I know it looks a little terrifying, but it actually guides your thought process through this entire thing, okay? And every bit of this has a reason to be on here, even the little triangles at the top. So I'm going to explain what it means, and then I'm going to give you time to get it down in your notes somewhere or on a sheet of paper or something so you have it. Now, on the top, we have the word unique. Under unique, you have a triangle with a 1. It's because if something is unique, there is only one of them. There's only one Jack. There's only one Noah. There's only one Cordy. Okay? That's unique. Then we have not unique. In the triangle below it, it says many. If something is not unique, I can create many of them. And then we have impossible. And under impossible, you have a triangle with an X on it, which basically is telling you what? So what? There's treasure there. There's no possible triangle. It is impossible. All right. What I'm going to give you is I'm going to give you 3 angles or 3 side lengths. Your angles will have degree signs. Your side lengths will have a measurement unit with it. So your first box is asking you a question. Have you been given 3 angles or 3 sides? Well, if you've got 3 angles, you follow the side that says angles, and it takes you to your next question. Do the 3 angles add up to 180? If they do, then we follow yes and see that this would create a not unique triangle. That those 3 angles could create many triangles. If they do not add up to 180, we know that no triangle is possible. It's impossible. All right? But if I gave you 3 side measurements, you'd follow down on sides, And you're back to what we were testing a few minutes ago. Do the two smallest sides add to be greater than the longest? Well, if it's a no, we know that it's impossible. But if it's a yes, it takes us down to the fact that we have now created a unique one-of-a-kind triangle. I'm going to give you guys a few minutes to copy this down onto something. You're going to need it. There's going to be lots of questions coming up, and you're going to need to learn to process through this type, and I am out of paper in the window. I am sorry. All right. I'm going to leave this up on the screen, but I want us to look on the page that you're at. If you look to the top right, we've got 6 questions. The first question, you're given, I'll write it over here, 8M, 1M, 8M. What does the M stand for? Meters. Okay, so since they've given us a measure of units, do we have angles or sides? Okay, these are side lengths. So if I go down the side where it says side lengths, do the two smallest sides add to be greater than the longest side? So I'm looking at my measurements that I've got. From 8, 1, and 8, I would have 1 plus 8 is greater than 8. Do the two smallest sides add to be greater than the longest? Yes. 9 is greater than 8. So since it says yes, we would classify this as unique.
Who texted me?
Anderson, I'm going to need your phone, please. Oh, man, that's recorded, too.
Why would you do that?
Okay.
I told you to call it.
I'm not calling.
Okay, let's look at number 2. We have 30 degrees, 70 degrees, 80 degrees. So, first question, are they angles or sides? Daniel? They are angles. So I go down this side where it says angles, and it asks, do the 3 angles add up to 180? Daniel?
Well, I don't even need a calculator for this. I know that 30 plus 70 equals 100, and then 100 plus 80 equals 180. So it's ununique.
Okay, so it is a yes, and it classifies as not unique. Kind of see how the pathway of thinking occurs on these? Okay. I go to number 3, and number 3 is listed as 3-inch, 3-inch, and 3-inch. So first question, are they angles or sides? They are sides. Do the two smallest sides add up to be greater than the longest? Yes. 3 plus 3 is greater than 3. So yes tells me that this would create a what triangle? A unique triangle. So unique, is that many triangles or one triangle, Anderson?
Who texted me?
Does unique mean one triangle or many triangles? Unique? One triangle. All right. Let's look at the next one on that paper. We have 1 centimeter, 4 centimeter, 10 centimeter. Are these angles or sides? Okay, down sides. Do the two smallest add to be greater than the longest? I'm hearing some mm-ms. 1 plus 4 is not greater than 10. So this would be classified as impossible. Very good. All right. The next one we have for question 5. We have 90 degrees, 40 degrees, and 40 degrees. Are these angles or side lengths, Fisher? They are angles. Do they add up to 180?
No.
No, so this would be classified as
Impossible.
impossible. Very good.
0% certain.
All right, the last one on that section, we have 178 degrees, 1 degree, and 1 degree. Are they angles or sides? They're angles. Do they add up to 180? Yes, so this would be,
What's calling you?
what is this classified as? Not unique. Very good. Okay, I want you guys to do the next set of 6 questions.
I think that was
We've already done these. I want you to do these 6. Now, it says 1 triangle. What do we know is 1 triangle? Hank? Unique. What is more than 1 triangle? Not unique. And then what is no triangle? That's impossible. So we've got similar wording that we can use, same type of question. So use that chart and answer these 6, please. Okay, the first one, we have 1.5 yards, 5 yards, and 3.5 yards. Are they sides or angles? They're sides. So what do we need to test?
If they
Ayla.
Are greater than the longest.
Good. The 2 small have to add to be greater than the longest. So 1.5 and 3.5 add up to be 5. Is 5 greater than 5? No. So can I have a triangle? There's no possible triangle here. Number 8. Sides or angles?
Side.
Those are sides. So how do we test it, Noah?
How do we test it?
Yes, how do we test it?
You add, right?
What do we add?
The 2 smallest items
What are the 2 smallest side lengths?
on number 1.
Number 8.
Number 8? 8 and 9.
8 and 9. So what's 8 plus 9?
17.
So that makes a triangle.
No.
No. You are correct. He was a little scared there for a minute. Number 9. Do we have sides or angles? Eleanor. Those are angles. How do we test angles, Jack?
You gotta see if they add up to 180.
Very good. Cam, do these add up to 180?
Which one?
We're on number 9.
So you see, it adds up to 180.
So, do I have 1 triangle or more than 1 triangle?
1.
Uh-uh.
Half.
Angles are not unique. That's the chart that I told you guys to write down. It's on the front of the room as well.
Oh, I did write it down.
It's beautiful handwriting. Looks just like Cordy's. It's on the front of the board. On the angles, when we go down the left, since it said yes, those are not unique. Only side lengths are going to be unique. Okay?
Yes, ma'am.
Number 10, do we have sides or angles? Anderson.
Number 10.
Yes.
You have the angles.
We have angles. How do we test angles, Hank?
By adding them together and seeing if they add up to 180.
Very good. We're looking for a sum of 180. Do we get a sum of 180 on number 10, Alex?
I don't believe we do.
We do not. So would we have 1 triangle, more than 1, or no triangle?
I don't think there'd be a triangle with this.
Yeah, I agree. No triangle. Number 11, do we have sides or angles? Marion. Number 11. Those are sides. How do we test sides, Josh?
Yeah, the lowest one.
Add the lowest ones. Okay. So 3.7 and 1.3 gives us how much, Cameron?
5.
Gives us 5. So will that create a triangle?
No.
No triangle. Number 12. Do we have sides or angles, Harrison? Those are angles. How do we test the angles?
If they add up to 180.
See if they add up to 180. Does 90, 90, and 90 add up to 180? No. So we have
No triangle.
no triangle. Very good. All right, folks. I want you to flip over a page. You are not going to complete all of the page. I am changing the directions. You ready? Don't look bad. I promise. It's not terrible. I want you to tell me if it's unique, not unique, or impossible. So using those 3 terms from our chart. And you are only doing the multiples of 3. So which questions are we doing if we're only doing the multiples of 3? 3, 6, 9, 12, 15, and 18. You got 6 questions.
Can I put UP or I?
Wait, what?
Unique, not unique, or impossible. However you abbreviate it is fine. But I want us to be focusing on the unique, not unique, impossible terms. Yeah. And we're going to turn around, get 6 questions done, and that'll be what we finish on.